Hello everyone. So today we're going to prove an equation from set theory. So this is like a discrete math topic. And we're going to prove that, starting from left to right, the difference between the set A and the difference between the sets B and C equals the difference of A and B union A intersects C. So we're going to be using set identities. Now, a lot of the time when we prove a fact that two sets are equal to each other, we prove that one set is a subset of the other one and vice versa. Okay, so that's not what we're going to be doing here today. It's not saying that's not doable here. You can try it out, but that's not what we're concentrating on. And as I said, we're going to be using set identities and actually one theorem here. A theorem is the difference between A and B equals A intersect B complement, which comes almost immediately from the definition of the difference between two sets. And we have these we'll call identities here. And these identities are very common in a lot of discrete math classes in terms of like writing them out in books, etc. There's a lot of them, and yeah, we don't have time to go over all of them and write them down, but there's plenty of them, and I suggest you go look at them. These are the ones that I'm going to be using today. So the first rule says, it's called the complementation law, which says that the complement of a complement is the original set. The second rule is a distributive law, which says if you have A intersect B union C, it equals A intersect B union A intersect C. So you can think of like the and intersecting here. And then finally we have what we call DeMorgan laws, which say that if you take A intersect B and you take its complement, it's equal to the complement of A union the complement of B. Okay, so let's go ahead and get started. And the way I'm going to proceed here is I'm going to go from left to right. You can go from right to left, or you can work with both sides of the equation here and get to a common point. It's up to you. But anyways, so the first thing I'm going to use is that first rule that I write, or theorem, which says that you can rewrite the difference between two sets as the intersection of a set and its complement. So you can rewrite this as A intersect B minus C, sorry, complement, not B minus C, the difference of B and C. I might say that again, my apologies there. So, and then what we often do when we're proving these results is we write the theorem that was applied. So I applied A minus B equals A intersect B complement. Okay. All right, so that's the first thing we can do. But see, I see that again here, where I have the difference between B and C here. So I can rewrite this as A intersect B intersect C complement. Okay, let me just move this a bit so I can give myself some space to write. And my reasoning here is the same thing that I did last time. Okay. Then what? Well, I noticed that I have over here the complement of an intersect, so you can apply DeMorgan's rules there. So this would be A intersect B complement union the complement of the complement. So here are DeMorgan's laws. And then, so we're almost done here. A intersect, well, the complement of a complement is the original set, so we use the complementation law here on the C complement. And then finally, what can I do? Well, I have a distribution. I have an intersect and parentheses a union, so I can rewrite this A intersect B complement union A intersect C. So like a distributive law here. Making sure that's the name of it. So many names. Sweet. And then finally, A intersect B complement is equal to A minus difference of A and B. Okay. complement union A intersects C, and that does it. Okay, so there we go. At the beginning when you're doing these, it's not that easy to see which step to work with in terms of the laws and identities, but often I tell people, look for something you can kind of transform, and that's what the whole thing with the difference between two sets A and B or whatnot, equals A intersect B, B complement. That's really useful when it comes up. Okay, so use any chance when you recognize something to use it to your advantage to rewrite things out. And then, yeah, just kind of this goes down further and further until you reach that point. And yeah, it's going to take a while for sure to get good at these. All right, well, I thank you for your time. Hope this helps.